Hello, and welcome to this installment on our series on formal arguments. In this part 4, we'll be discussing the rules of logical equivalence. So, where we left off, we were talking about operator scope, and we discussed how the range of components to which an operator applies is called the operator scope. We use parentheses to indicate what the limits of an operator are. It's important to denote which operators apply to which components. Logical equivalence occurs when two propositions have the same exact truth values. It's like saying the same thing in a different way. And today we're going to look at some of the rules for how it applies to form. How we can put something in one form and that means that it also fits in another form. The first and probably the most intuitive of these, especially to English language users, is the double negative. And essentially this just says that when a negation is applied twice, the result is equivalent to the original proposition. Since negation inverts the truth value, another negation would invert it back. And you'll notice during this presentation I've just pulled the logical operator truth tables for your reference. Again, this just is to say not P is the same thing as P. The next property we'll be discussing, or rule rather, is the commutative rule. And we discussed this earlier when we went over logical operators. Both the disjunction and the conjunction have the commutative property. Given any disjunction or conjunction, the components may move about the operator without affecting the truth value of the claim. In other words, apples or oranges is the same thing as saying oranges or apples. Likewise, peas and carrots is the same thing as saying carrots and peas. Although I must remind you, when you're actually using these to determine validity, you will be using entire sentences and not just subjects. That's just an example. Next is the associative property. This may look familiar to those of you who are mathematicians. The scope of a conjunction in which one of the conjuncts is itself a conjunction does not affect the truth value. The same applies for disjunctions whose disjuncts are disjunctions themselves. And I realize that this may sound a little bit like I'm going in a loop, but you'll see here this is a conjunction. The main operator is a conjunction right here. One of the conjuncts is R, the other conjunct is P and Q. And this is saying if you had P and Q and R, it's the same thing as saying P and Q and R. Those ands, the scope of this operator does not affect the truth value of the claim. You can see down here where we have the conjunction. Imagine another variable. It would extend the truth table down, but it would still be the case that for the and to be true, all three must be true, regardless of how they are associated with each other, in parentheses. Keep in mind, this only applies to the associative property only applies to conjunctions and disjunctions which have conjunctions or disjunctions as part of them. Notice this does not apply when you have a main operator of a conjunction and a subordinate operator of a disjunction. They both must be the same. Next, we have the distributive property. Again, this is probably one that math lovers will be familiar with. And this says when you have a conjunction with a disjunction as one of its conjuncts, or vice versa, the main operator can be distributed to the parts of the subordinate. This allows the exchange between and or statements. So you'll see here the main operator here is a conjunction. The conjuncts are P and Q or R. You can distribute this P and to both of the disjunctions in the subordinate. So therefore you get P and Q or P and R. To read the entire thing out, P and Q or R is the same thing as saying P and Q or P and R. And this works similarly for disjunctions which have a conjunct as a subordinate. P or Q and R is the same thing as saying P or Q and P or R. Here we have a more common sense rundown of this, and you'll see that it really does make sense. We don't necessarily think about these rules when we use them in speech. Consider the complex premise: I applied for a job, and I will either get the job or I will apply for another. That statement is the same thing as saying I applied for a job and I will get the job, or I applied for a job and I will apply for another. Again, it may seem trivial. In most cases of speech it is, but it's an important distinction to make, especially when using the logic language we have to determine validity. The next property we're looking at is the conditional exchange. This rule is especially important because it allows us to move from an or statement to a conditional, or to move from a conditional to an or statement. And the conditional exchange says a disjunction is equivalent to a conditional with a negated antecedent. And again, the antecedent of a conditional is the thing that comes before the arrow, the if part of the if-then statement. So, to read it out, we will have fish or chicken for dinner is the same as saying if we don't have fish for dinner, then we will have chicken. Notice in this case, the operator is an or, and the two disjuncts are we will have fish for dinner and we will have chicken for dinner. However, down here, the operator is a conjunction, right? An if-then statement. We still have the same elements, right? If we don't have fish for dinner, then we will have chicken. Remember that when applying this rule, it's important that the antecedent, the first part, is the element that's negated. This rule works because, as you can see, in a disjunction, one must be true. And by negating, it's essentially saying, given a disjunction, either P or Q must be true. If it's not P, then it must be Q. And you'll see this expressed in a rule of inference in our next lesson as well. Next, we have the biconditional exchange. The biconditional exchange states if we have a statement that says P if and only if Q, that's the same thing as saying if P then Q and if Q then P. A biconditional's components are both antecedents and consequence. A biconditional is equivalent to the conjunction of two conditional statements in which the components switch roles. Consider the clause, it is night if and only if it is no longer day. It's the same thing as saying, if it is night, then it is no longer day, and if it is no longer day, then it is night. Of course, one sounds much more wordy, but it is the same thing. The last rule of equivalence we're going to look at is Demorgans Theorem. This is often the rule that is the most intimidating to new students, but also it is quite intuitive as well. Try to follow along here. The negation of a conjunction is equivalent to a disjunction with both disjuncts negated. And the negation of a disjunction is equivalent to a conjunction with both of the conjuncts negated. So consider this one. It is not the case that we're going to use the or here. It is not the case that Tom is a mother or Bill is a mother. That's the same thing as saying Tom is not a mother and Bill is not a mother. They are equivalent. That's what this is expressing. If this is true, this will also be true. If this is false, this will also be false. So, moving forward, these rules are really meant to be used in tandem with rules of inference to determine if premises lead to a conclusion, or if an argument is valid, in other words. We will be looking at the rules of inference in the next video. Since the method we use to analyze validity looks at form and uses specific forms in the rules, equivalency can help us rephrase and meet criteria for other rules. It can help us to put the clauses in an order that is what the form is looking for and is equivalent to what we're trying to say. Sometimes you need an if-then statement instead of an or statement, and these rules help understand just how to do that and do it correctly so you transfer the logical equivalence. And finally, you should know that the rules that we've gone over today are not exhaustive. There are other valid rules of equivalency. These are just the more common ones. If you do find this interesting, or you find yourself needing to know more rules, be sure that you use the skills that we developed over the course of the semester to evaluate your source and find one that is good. Oh, look, that's the end of the slide. Congratulations, you made it. If you're hearing me, you're still awake. Good job.